In this video, we have so far talked about ionic compounds. And with your ionic compounds, these are the ones you're going to swap and drop. But as you swap and drop these compounds, sometimes you have to use Roman numerals. And sometimes you don't. Normally, you're going to see these all mixed up. When they're written out and you have to give the formula, those are usually pretty easy. People get those pretty much straight away because you see the Roman numerals like, oh, wait a minute, I need to use that. And then other times you don't have Roman numerals, or if you have the formula, you're going to have to write the name and you're going to have to figure out, do I need these or do I not? So I'm back to the periodic table that I have colored. I asked you to take a periodic table and write down the oxidation number. So like group 1 is a representative element, so is group 2. So is group number 13 down here. They always have the same oxidation number. With your oxidation numbers, group 1 is always +1, +2 for group 2, and then group 13, again, we skip over boron. Boron's weird, we don't really deal with that one. But everything else down below it is all +3. Now, if you are in the transition metals, which is everything in groups 3 through 12, tin and lead are going to get Roman numerals, and those Roman numerals tell you the charge of the metal itself. So I'm going to keep this handy. We're going to look at some examples here. When I look at these examples, I just made them up just so I could have something to talk about. But the first element that I see here is sodium. And when I look at that first element as sodium, sodium lives in group number 1. So because sodium lives in group number 1, it's a representative element. It always has a +1 charge. So I don't need to do anything different when I go to name this one. I just write down sodium, no Roman numerals, no numbers, anything like that. And then SO4 is a polyatomic ion, even though it's not in parentheses. It's not because there's only one of them, but SO4 is sulfate. You might have to look that up on your periodic table, but that's one of them that you should know from your 12. The next one is Cu. Cu is copper. Copper lives right here in the transition metals. So that means that I need to use Roman numerals to tell the charge that they used to write out this formula. So the way that we did that was we tried to reverse swap and drop. So I brought the 2 back over here to be +2. There's a ghost 1 right there, which goes over there to be -1. I need to check to make sure that that worked, that this wasn't reduced down. ClO3 on our polyatomic ion chart is -1. So that means that the 2 works as well. So I have copper 2 chlorate. The next one, Al. Al is aluminum. It's right here. Aluminum always has a +3 charge, so no Roman numerals there. So you have aluminum, and then Br is bromine. So in a formula, I even wrote it out wrong. In a formula, it's going to become bromide. I said bromine and then I wrote it wrong, sorry. Now this last one down here is Zn Zinc. Zinc is right here on the periodic table. Now we said in class, zinc always has a +2 charge. Even though it always has a +2 charge, it lives in this zone with your transition metal, so it's going to get Roman numerals. Now, if I wanted to go through this the long way, there's a ghost 1 and a ghost 1. I bring that number 1 back over here to be -1. That's not right. Sulfur on the periodic table has a -2 charge. So because sulfur has a -2 charge, this one must have been simplified down. Sulfur's -2, which means zinc, hey, look at that, is +2. It's always +2. And then sulfur is going to become sulfide. So as you're doing these, look at the first element. When you look at the first element, figure out, is it representative or is it transition? If it's a transition, tin or lead, it's going to get Roman numerals. If it's a representative element, it just stays the same. Now on these, when you have the names and they're all written out, these are pretty easy to swap and drop. If there's no Roman numerals there, you have to look them up. If you have Roman numerals, hey, they did the work for you. So calcium permanganate. Calcium is Ca. We look at our periodic table. When we look at our periodic table, calcium has a +2 charge. Permanganate is a polyatomic ion. So permanganate is MnO4 -1. So when I go to swap and drop, this ghost number 1 comes over here. The 2 comes over here. So you have Ca and then NnO4 2. The next one, lithium phosphide. Lithium lives in group number 1. It always has a +1 charge. So you have Li +1. Phosphide, IDE, means that it's phosphorus on the periodic table. So you have P, phosphorus has a -3 charge. Plus and minus disappear. 3 drops over here, the ghost 1 here, Li3P. The next one, scandium 2 chloride. Scandium is Sc. It has a +2 charge. That's what that means. So you have Sc +2. Chloride, IDE, is chlorine from the periodic table that has a -1 charge. So I go to swap and drop, plus the minus disappear. The 2 drops over here, ghost 1 over here, ScCl2. And then the last one, I have gold 1 phosphate. Gold is Au. This right here means that it has a +1 charge. So I have a +1. Phosphate, Ate. Ate means that it's a polyatomic ion. So PO4 -3. So when I go to swap and drop here, the plus and the minus go away. The 3 comes over here, the ghost 1 over here. So you have Au3, PO4. And again, for my class, I don't care if you put the PO4 in parentheses or not because there's only one of them. So this answer and that answer are identical. It's totally up to you what you want to do there. So I hope that helped to clarify a little bit on what to do if you have your ionic compounds, when you use Roman numerals and when you don't. Just remember to look at the first element if you have a formula, and then look at your periodic table, figure out where it lives. Transition metals, tin and lead, get Roman numerals. If it's a representative element, it doesn't get any at all. Have a good day.